All right, if you could just state your name and your title here.
Okay, I'm Dr. Kevin White. I'm a professor and chair of the Civil Engineering Department here at South Alabama.
And what degrees do you hold?
Okay, I've got a BS degree and a master's degree from LSU, and I got my Ph.D. in civil engineering from Virginia Tech.
Okay. What classes do you teach or have you taught here?
My master's and Ph.D. focused in environmental engineering, so my classes involve mostly environmental engineering related classes, although I do teach Senior Design 1, which is more about the design process and putting together bid packages, writing proposals, doing feasibility studies, some of the things that you would need to know that civil engineers deal with in practice, like sustainability and ethics and things like that. So, but mostly environmental engineering classes.
Do you have a favorite class to teach?
Probably my water wastewater class is my favorite class. It's interesting because the students are just beginning their senior year, and up until that point, most of the engineering classes are not really what I would call design oriented. They're problem solving oriented. So the students really are learning not only engineering science and engineering subdisciplinary information, but they're learning how to solve problems. And in your sophomore and junior year, that problem solving means I can set up a problem and solve it and get the right answer. Real design, there's not a right answer. There's a best answer, but there's not necessarily a right answer or only one right answer. And so in this water wastewater class, right out the door, right very beginning of the class, I give them, we're going to design a distribution system to distribute water to a small city. But they have to predict what the water demand is going to be 25 years from now. And so that means they need to predict what the population growth is going to be 25 years from now. And there's different ways of doing that, and so which is the best way of making that prediction? There's not just one formula, there's multi-formulas. We have to predict how much fire flow would be needed to put out a fire in this community, and there's 2 or 3 insurance-based formulas. We have to determine how much storage we need for a storage tank in the water system. So if we have a fire, we've got water to put it out that's above and beyond what's coming from the treatment plant. There's different ways of calculating that volume. So it's an exercise where the students are sort of looking at the big picture now, not just one little small problem.
Right.
And it takes a while to kind of get used to that. But it's nice for me when I see the light come on and they start to recognize that I just need to know what I'm trying to get to. And I'll look at it from a couple of different ways. This one looks the best. And so when I see them do that, I know they're going to be a good engineer.
Do you think that's when you really start transitioning from being a student to an EIT?
Yes. It's when you start getting that it's not just solving a problem to get an answer and I can look up that answer in the back of the book. That's just problem solving. That's not design, that's not engineering. But when you understand that I'm trying to size something or develop something that's going to work to solve a problem, you can get to that in 2 or 3 different ways. And I can evaluate those 2 or 3 different ways and use my own judgment to determine which one is really best, based on cost, based on performance, based on constructability, based on something else.
Yeah, very cool. Why did you choose civil engineering, or how did you come into?
I started out in. I actually started out college in biochemistry.
Okay.
And I always liked chemistry and biology too. And then I was sort of introduced to environmental engineering, which was applied chemistry and biology.
Right.
And that just really interested me. Instead of just studying the chemistry or studying the biology, we could use that to solve a problem, to remove a pollutant from drinking water or wastewater, or to clean up a hazardous waste site, or something that I felt was beneficial, to people or society. And that's really what kind of turned me on to it. It was applied science and math.
Okay.
So that's really why I made a sort of direction change and went into environmental engineering.
How long have you been here at South?
I started here in January of 1991, so January of 18 will be 27 years. So quite a while.
Why do you think you've stayed here that long? And part of that is what makes the program here special to you?
I came here in 1991. It was a small department. We were in another building. We only had 6 faculty, I think, at the time. We were only graduating 10 students a year. And I came here partly because it was a chance to help build a program, because it was a small program. Most of the students did not stay on campus. They were commuters. They come in, take class, go back to work, or go back home. So it was kind of a chance to build something. The department chair that hired me, Joe Olson, was a geotechnical engineer. That was his discipline. But he got all 3 of his degrees from MIT. So he was a pretty sharp guy. He taught geotech, and man, he was really tough on the students. But he hired Dr. Omar, who's also still here, and is a great teacher. He hired Scott Douglas, who just retired a couple of years ago, and Scott's a preeminent coastal engineer in the nation, really. So he hired a bunch of good people, and so the department was a good place to work. He gave us, he didn't know a lot about environmental engineering. He knew a little, but he gave me enough freedom to develop what I thought would be a good set of classes for the curriculum. And I enjoyed teaching them. I enjoyed doing research, and I was able to do that. So, you've heard the expression, little fish in a big pond, or big fish in a little pond. Well, it was kind of like I was a big fish in a little pond, because we were small. We were South Alabama. We weren't Auburn. But yet I got to do things on a local, regional, even national level, and interacted with different people in different places, and they knew who I was and what I was doing at South Alabama. And that's still true today. And that's true of our faculty today. So people around the country know Brett Webb. He's coastal engineer, and he's on all kind of national committees, and people in Delaware and Washington State, they know who Brett Webb is. Same thing for a lot of our faculty. So it really was the chance to build a program without the tremendous pressure of having to support 5 Ph.D. students and 15 master's students and publish 4 or 5 papers a year that you would have to do at a big school.
Okay. So now we get into advice. Do you have any advice for a student while they are here at South?
Yeah, a couple of things. One, you're in college. You should enjoy it, because when you graduate and you go to work, you're going to work the rest of your life. There's no going back. Or it's hard to go back. Let's put it that way. It's difficult to go back. So keep that in mind. There's a lot of people that want to hurry up and graduate and go to work. Well, that's okay if you want to do that, but you're not going to get these 4 years, 5 years back. So enjoy it while you can. So I would say my advice is to enjoy your time in college, but at the same time work hard to make decent grades. And there's kind of a balance there, right? Mm-hmm. And you can do it. Most students can do that. It's time management. You don't have to be a genius to graduate in civil engineering or any other engineering, but you do have to be committed to it. So you have to manage your time and say on Sunday afternoon, I'm going to study for 2.5 hours because I need to. Or on Wednesday nights or on Thursday nights or whatever night you pick. And there should be multiple those, but you've got to stay consistent with that and be committed to passing your classes. And if you keep up with it, if you read the material, if you go to class, try to understand the material, work some extra problems if you need to, talk to your instructor, you'll be successful.
And any advice for post-graduation?
I would say two things. Back to pre-graduation, try to find an area that you like to focus on. Mm-hmm. If you find you love to do structural kinds of things, take your tech electives in structural. Go to work in structural because you like it. Don't just take any job just to have a job. And you may have to do that, but try to work in an area that you genuinely have an interest in because you're going to be happier. You're not going to dread going to work every day. And that's one thing I can say for myself and most of the faculty in this department. I think we all like what we're doing. We like to come to work. It's not always fun, but it's not something that we dread. So we like teaching class, we like teaching students and interacting with students. We like to see students succeed. So when you get a job in post-graduation, hopefully you're in something that you truly have some interest in. And it will be a joy to get up and go to work every day, not something that you hate or you dread and you're not interested in. And if you're in that situation where you don't like something, that's a sign that you probably should be doing something else or doing something at another company because this one's not working out too well. Life's too short to not have some positive effect about going to work every day.
Yeah. Is there any research that you're still currently a part of?
Yes, we're doing a couple of things here on campus right now. We've got a project, stormwater related. A large part of the campus drains into 3 Mile Creek. That's the wetland over there by the med school. And 3 Mile Creek is a priority watershed for ADEM, the Alabama Department of Environmental Management. They're trying, I say they, the city and the Mobile Bay National Estuary Program and others are trying to restore 3 Mile Creek to a more natural type of creek. They're trying to improve recreational opportunities, put in walking trails, kayak launch points on the downstream end. And South Alabama has been identified as a contributor of a lot of sediment to 3 Mile Creek. And it's barren areas of campus that run off and erode and the sediment gets into the creek. So we got a project, we got some funds from ADEM, EPA and ADEM, to put in what's called a low impact development best management practice. It's a linear bioinfiltration swale. So it's a linear depression that's filled with gravel. It's only a couple of feet deep, filled with gravel and mulch. It's planted, so it looks like landscaping, but it's actually capturing runoff and infiltrating that runoff into the ground instead of allowing it to go on down and erode and put sediment into the creek. So we've just implemented 3 or 4 of those over by the administration building, and it looks like we're going to get another set of money to do similar things in the humanities parking lot, which is a big parking lot. It's on a slope. The water all rushes down into the inlet, gets into a little gully, and it's washing out the gully. The bridge over the gully is half falling down. And so if we can do the same thing and minimize some of that water getting to the gully, we can stop the erosion, stop the sediment transport, etc. So we're doing those kind of things right now. I'm also involved in some projects up in the Black Belt region of Alabama, south central Alabama. It's an area that is mostly rural, mostly low income, 30% of the population below the poverty line. And the soil conditions are made up of clay. So when you're in a rural area, you typically would use a septic tank and a drain field to handle your wastewater from your home. Well, in this region of Alabama, water will not go into the ground. And because of that, there's about 50% of the homes in this region of Alabama and parts of Georgia and Mississippi that have raw wastewater on the surface of their yard. Some of them just connect a pipe from the toilet out into the yard and it just runs out on the ground. So, and there's about 15 or 20% that way, so it's huge.
Wow.
That's a public health problem. When you have 50% of the residents that have raw sewage in their front yard or backyard. So that's a public health problem, and we're trying to work with the health department, ADEM, EPA, USDA, rural development. And we just had a meeting where we brought down the product development team for American Standard, who develops all kinds of toilet type products all over the world for Africa, Australia, US, Europe. And they're going to try to help us come up with some type of new sanitation device that can help eliminate this problem in the Black Belt. So those are the couple of things I'm involved in right now.
That's awesome. That'd be great if we could get that figured out.
Absolutely.
Is there anything else that you would like to add for, a prospective student or someone that's on the fence about?
Well, I would just say civil engineering is a pretty broad field, and most people don't know that. Certainly most high school students don't know that. If you're a high school student and you don't have a mom or dad that's a civil engineer, somebody says civil engineering, you probably think of roads and bridges. But that just scratches the surface of what we do, all the water, wastewater, stormwater, drinking water.